This is the video to help you complete the electrostatics lab. In our first step, we are going to make our electroscope. You will need a mason jar or any glass jar. This is a 16-ounce jar, and it's nice to have a jar with slightly flattened sides so you can clearly see whatever is inside. The mason jars come with a two-part lid. I've lost the inside part here, but this is the outer locking ring, and there is normally a metal cap that goes on top. You only need the outer locking ring. If you don't have a jar with a cap like this, then simply we can work around that, and I'll show you how to do that. You need a plastic bottle cap to act as an insulator, a paper clip, some cardboard, and some aluminum foil. You'll also need a knife and a pen to mark out. In step 1, we will cut out a lid out of cardboard to replace the metal one. So just trace around the inside of your lid like so, and we're going to cut that out. So you can use your knife just to cut that out. Once you've cut it out, make sure that it actually fits in here, doesn't go through, and can be screwed onto the top of the jar like so. Now we've made our replacement lid. We've used cardboard, as cardboard is an insulator compared to the original plate, which is metal. Next, we're going to place our plastic bottle cap so that it protrudes like so, and mark around it. We're going to cut out the hole so it's slightly smaller than the outline of the bottle cap. We need to make the hole slightly smaller so that we can rest the bottle cap on top and glue it on afterwards. So once you've done that, you can remove this piece and cut the middle out. The next step now, I'm going to zoom in. The next step is to make a little hole so that the wire that forms this paper clip can fit through the center. Just want to make a small little hole. You can use your knife to do this, and just twist your knife gently, pushing just a little bit until you've made a tiny hole. Now we are ready to glue our bottle cap to the top of our cardboard lid. So you can screw that back on and center the inner hole. Put your bottle cap on top and just put a dab of glue in three or four spots to secure the bottle cap onto it. That should be fine. So you can see I've just put a dab of glue at about 3 spots there just to secure it on. Now I'm going to leave that to set. In the meantime, I'm going to straighten my paperclip and I'll show you what's involved there. Open it like so, then like this, bend that down and straighten that out. So you have something looks like that. In our next step we are going to secure our conductor within the insulator cap. Pass the straight end of the bent paper clip through the hole you made in your bottle cap until it protrudes about 5 millimeters, like so. Turn it over and just support the cap like so, so that the hooked end points vertically upwards, and use some hot glue just to secure it in that position. So I've applied some hot glue in there and just hold it there until the glue is sufficiently set so that the hooked end is held vertical. This is what the finished object should look like once the glue has set. The next step is to make our electroscope leaves. Smooth down the aluminum foil and cut 2 pieces, roughly 1 centimeter by 2 centimeters. Be very careful not to crease the leaves that you are cutting out. So use a sharp knife to cut those out very gently. Like so. Make sure they're nice and flat and roughly of equal length. Then cut a small square on top of each leaf that is about 2 to 3 millimeters square, like so. Once again, be very careful not to crease the foil. There's one. Let me do the other one now. Turn that over. Once again, just gently smooth and flat. And here are your electroscope leaves. To complete the electroscope, gently hook your electroscope leaves onto the end of your conductor. Once again, be very careful not to crease your leaves. They should hang freely. And there we go. Let's put the electroscope leaves, or put the structure there with the hanging leaves. and have the side of the leaves facing one of the flat areas of your jar so you can clearly see them side on from a side view, and screw your lid on. Like so. Here is a completed electroscope. We see the conductor at the top, the insulator, and the electroscope leaves. To test your electroscope, take a plastic rule like so, and a cotton t-shirt. Charge the plastic rule by rubbing it against the cotton t-shirt, and then touch the rule to the electroscope. You should see the leaves separate like so. This shows that our instrument is working as intended. Once charged, to discharge the electroscope, just touch the top conductor and the leaves will collapse, because the charge on the leaves will be shared with your body and everything that your body is connected to, leaving very little charge left on the electroscope. So that's how you discharge an electroscope. The charge on a common plastic ruler when rubbed with cotton will be a negative charge. This electroscope has been charged using the ruler that has been rubbed with cotton. Hence there is a negative charge on this electroscope. We can now use that information to detect the charge on other charged objects. For example, take this balloon. I am rubbing it with a cotton cloth, and when I bring it close to the electroscope, we see the leaves are deflected outwards. I'm not touching it to the conductor, just simply bringing it close. This means that the charge on the balloon is the same as the charge on the electroscope. Hence this balloon has a negative charge on it. We can use this method for other household objects that are charged by rubbing with another material to determine the sign of the charge that is deposited on them. So please try this with 3 different combinations of cloth and the solid rigid material to determine the charges on those objects. And that's the end of the experiment. Thank you.